Good day and welcome to your math lessons with your subject teacher, Miss Lyrene May Santiago. This is the quick flashback of your math lessons from your lower years. Exponents. What is exponent or what are the exponents? In a raised to n, a is called the base and n is the exponent or index. We may read it as nth power of a or a to the nth. If n is equal to 2, we read it as a squared. If a is equal to 3, we read it as a cubed. Again, in a raised to n, a is what we call the base and n is what we call the exponent or index. If n is a positive integer, a raised to n represents the product of n factors, each of which is a. Thus, a raised to 4 means a times a times a times a. 2 raised to 4 means we multiply 2 to itself 4 times. That is 2 times 2 times 2 times 2. And it is equal to 16. Another, we have here negative 5 cubed. That is negative 5 times negative 5 times negative 5, and that is negative 125. Some more examples, we have here 4 raised to 4, that is equal to 4 times 4 times 4 times 4, and it is equal to 256. How about 2x squared? That is 2 times 2 and x times x. We have here 4x squared. How about negative integral exponent? If n is a negative integer, we define a raised to negative n. It is equal to 1 over a raised to n, given that a is not equal to 0. For example, we have here a raised to negative 1. It is equal to 1 over a. Notice that a raised to negative 1 became a raised to positive 1 and we transfer it to our denominator. Another example, a raised to negative 4, and that is equal to 1 over a raised to positive 4. Another examples, we have here 2 negative 2, and that is also equivalent to 1 over 2 squared. In other words, we have here 1 over 2 times 2, and 2 times 2, it is equal to 4. In other words, 2 raised to negative 2 is equal to 1/4. Another example, we have here negative 4x raised to negative 3. Notice that in this example, only x was raised into a negative exponent. In other words, only the variable x will be transferred to our denominator. So we have here negative 4 and x raised to negative 3 will be transferred to our denominator and will become positive. That is x cubed. How about zero exponent? If n is 0, we define a raised to 0, it is equal to 1, given that a is not equal to 0. In other words, any number raised to 0 is equal to 1 except 0. We will see. X raised to 0 is equal to 1. 2 raised to 0 is still equal to 1. 10x raised to 0 is still equal to 1. Quantity 2x squared raised to 0 is equal to 1, but 0 raised to 0 is indiscriminate or undefined. How about the rational exponent? If m and n are positive integers, we define a raised to m over n, and n will become the index of the radical, and a and m will be the exponent of the radicand. Don't worry, we have here some more examples. 2 raised to 2/3. Observe that the denominator 3 became the index of the radical, and 2, which is the numerator of the rational exponent, became the exponent of 2, and that is 2 times 2, that is cube root of 4. Another example, 2 raised to 1/2. Notice that the denominator 2 was not written as our index because we read it as square root of 2. So when there is no index number, in other words, when there is no index number in a radical, it is already considered that the exponent of that number is 1/2. Another example, 5 raised to 3/4. 4 will become the index number and 3 will become the exponent of 5. That is read as 4th root of 5 cubed. Another example, 2 raised to 3/5. 5 will become the index number and 3 will be the exponent of 2. That is read as 5th root of 2 cubed. Here are some of the laws of exponents. If P and Q are real numbers, the following laws hold. Rule 1. If we multiply variables, we add their exponents. For example, x raised to 5 times x raised to 6, it is equal to x raised to 5 plus 6, and 5 plus 6 is 11. In other words, the product is x raised to 11. 2 squared times 2. We all know that 2 alone, the exponent of 2 is 1. That is, 2 plus 1 is 2 cubed. And we all know that 2 cubed is equal to 8. Another example, we have here x squared times y squared. Notice that we didn't add the exponents because they are different variables. X and y are different, so that we will not add their exponents. So the final answer is x squared, y squared. Second rule. Quantity of x raised to p raised to q. If a variable is inside the parentheses, we multiply the exponents. For example, we have here quantity x raised to 5 raised to 6, that is 5 times 6. It is equal to 30. Another example, 5 raised to 4 raised to negative 3. 4 times negative 3 is negative 12. Applying negative integral exponent, since the exponent of 5 is negative, we will transfer 5 raised to negative 12 into the denominator. And the final answer is 1 over 5 raised to 12. Another example, 2 raised to 2 raised to 0. We all know that any number except 0, when raised to 0, it is equal to 1. In this rule, we will just distribute the exponents. Example, we have here xy raised to 6, that is equal to x raised to 6, y raised to 6. Another example is 2x squared raised to 2. So we just have to multiply the exponents. We have here 2 squared, and 2 times 2 is 4. The final answer is 4x raised to 4. 2 times 3 squared, that is equal to 2 squared times 3 squared. And 2 squared is equal to 4. And 3 squared is equal to 9. And 4 times 9 is 36. Same process. We just have to distribute the exponent to both numerator and denominator. So we have here x raised to 6 and y raised to 6. Another one. 2 squared, it is equal to 4, and 3 squared is equal to 9. This is the division rule. For example, we have here x raised to 8 over x raised to 4. We can see that in the given fraction, they have the same variable. In other words, we can subtract their exponents. So we have here 8 minus 4, and it is equal to x raised to 4. Another example, we have here y raised to 4 over y raised to 8. Since they have the same variable, both the numerator and the denominator, we can subtract the exponents, just like 4 minus 8, and that is equal to negative 4. Again, applying the negative integral exponent, we will transfer y raised to negative 4 into the denominator, and the result will be 1 over y raised to 4. Those are the laws of exponents and some definitions of the exponents. I hope you learned something from this video. Thank you so much, and